Welcome to the Prosthetics and Orthotics Podcast with Brent Wright and Joris Peels. Brent and I are both very, very curious about the orthotics and prosthetics world. And we're trying to figure out what role 3D printing or additive manufacturing is also called, and generally digitization, so 3D scanning and CAD and all the tools that are coming from that world as well. What these tools will mean for patients and also for practitioners. And Brent Wright's a super experienced O&P professional. He also does a lot of work on this digitization field. He 3D prints sockets, things like that. I am a 3D printing consultant and know very little about that world. And together we're curious about this. We're trying to explore it with some people from the industry. And that's what we're doing. And so Brent, who'd you bring for us today?
Hey, yours. This is going to be a fun one today. We've got Derick Schmidt with us, and just a little bit about Derick. He has been doing digital design and such for quite a while now. He really has pushed some of what is possible in the FDM realm. He has gotten into the nitty gritty of slicer settings and all that stuff, and We've just really hit it off. We run in very similar circles, but he does a lot of things that make it and training. And I know, Joris, we've talked about training before, of where there's just a lack of training for digitization in the O&P world. And that's one of the things that I'm excited to hear Derick share a little bit about on is his company that does some of the training, and really just what he does to advocate for the digital workflow for our field, while keeping it to where clinicians are still driving the boat for good outcomes for patients. So really excited to have Derick with us today.
Okay, cool. Welcome, Derick.
Yeah, thanks for having me, guys. This is looking forward to it. This is going to be exciting.
So first off, how'd you end up in O&P? Because that's, to me, it's always it's never it's always a kind of very many varied answer we hear every time. It's always kind of all over the place. So how did you end up in this field?
Yeah, I always tell people I don't really have the good story. I didn't see an amputee and have my life changed. It probably starts back in high school. So I don't know, 20 years ago, I took a lot of CAD classes, some robotics classes, and I really liked that. So going into college, I was going to do mechanical engineering until I realized how much I don't like calculus and chemistry. So I got out of that and ended up in kinesiology. So I was exploring physical therapy, really didn't know what I wanted to do, but was most drawn towards biomechanics. I love physics, the non-calculus type. And eventually I was coming up to senior year. So end of junior year, I had a meeting with my advisor and basically didn't know what to do or where to go next. And was realizing at that point a kinesiology degree is kind of one of those degrees that gets you to another degree. And I had to figure out what that was going to be. And she pulled out a list of things that people have done after kinesiology. And way down at the bottom of the list, she said, we've had 2 or 3 people over the years go into this thing called prosthetics. She was like, I don't really know what it is, but you could look into that. And here I am. So for me, it was basically a way to bring it all back together. The mechanical engineering part of it, those things that I liked, the robotics, the biomechanics, working with people. And kind of from as soon as I knew about it, what I really wanted to do was figure out how to use CAD and figure those things out. And I quickly learned that there is some CAD in the field. At the time, it was just basically limb modifications. And that was never really enough for me because I knew more. I knew more about CAD. I was trained a little bit on SolidWorks and Inventor. And I always wanted to figure out how to take that next step. And finally, about 10 years later, I figured out 3D printing. A lot of it was seeing Brent's stuff on LinkedIn. And at that time, I realized that's it. That's how I bring it all together and take control of the things that I want to do. So here we are.
Okay. I think it's interesting that you came in with CAD experience. So it seems that standard O&P education doesn't include a ton of CAD stuff up until now. And a lot of people we talked to so far, if they had to go into 3D printing, they have to start with CAD all from from scratch. Do you think that changed your thinking and changed the way you approach a case because you're more CAD fluent, or you started more with CAD?
I think it can. I've got that experience of thinking about things in 3D space, and I don't know that that's necessarily a CAD thing. I've seen other people who are able to do that and just don't know CAD. But I think there is something about being able to think about things in three dimensions and then translate that from, whether it's from your brain to your hands or your brain to a mouse. It's kind of all the same line of thinking. So yeah, I was able to pick up the CAD designing and 3D printing part easier, but I think a lot of people could do it if they are the type of people that think that way.
And when did you first start to get in touch? Because for you, 3D printing is much more adjacent then. So when did you first start to get in touch with 3D printing then?
Probably about 2018. So we're probably at maybe 4 years here. I met Brent at a little like education symposium up here in Ohio. I was just kind of following along until that point, and that's when I started doing a little bit of design work for some MJF parts. Just some basic things. We tried to make like a prosthetic leg cover and some SMO, some little short foot ankle orthotics. And really, I just started there. That was kind of my introduction to 3D printing. And then I realized at the time that was what was going to be the path that would allow me to really take the ideas I had and make something out of them. Prior to that, I was thinking, I might want to work for a manufacturer, but then I would just be stuck doing the projects they wanted me to do. And 3D printing kind of opened up my eyes to the idea that I can do the things I want to do. If you can design it, you can print it. It just matters which printers you have access to. You have to know the different processes. But so it's probably about 4 years ago I started with MJF, and then I moved pretty heavily into researching resin. I wanted to do lattice work. My company is called Limb and Lattice, and it started with that. And I saw the Adidas shoes and then some of the bike saddles that were providing cushioning. And I wanted to bring that to prosthetics and orthotics. So I started researching into that a lot, and eventually realized that, that might be a little ways off, that the resin printers capable of doing those things might not be accessible at this time. And that's when I really switched to FDM, just more so for the daily workflow. When I realized that, at first I was like a lot of people, I didn't believe in FDM really for O&P. But then when I got into it, saw what some people were doing, and I bought my own printer in January of 2021. So we're at about a year and a half that I've been doing FDM. And it's far more powerful and capable than I thought it would be.
So why did you just start doing SLA, SLA or VAT polymerization, or as a group of technologies, essentially? Usually there's also DLP, but people kind of use them interchangeably. So that's a technology that makes a photopolymer, takes a photopolymer and makes a very delicate but very detailed object out of light, essentially. So what? It was specifically for lattices. You thought that would be the technology and that would be the way forward, or what did you find out about SLA? Because we haven't had anyone that had really a lot of experiments with SLA.
Yeah, I figured out that it probably isn't what we need, and people had tried to tell me that. But yeah, I looked into it because of specifically the lattice testing and seeing some of the things that were coming out. The tough rubber product, I had seen that early on, and I thought that could have some potential. And I ended up working with a lot of the different companies. I did some testing with Carbon. Ended up doing some testing with Envision Tech, and then actually the tough rubber itself with I think it was Adaptive 3D or Additive. What's that? I forget what that one's called. But yeah, tested out a bunch of those, and I realized that I bought myself a desktop MSLA printer, and just everything I made would just over cure over time and get brittle. And as I talked to people in that field more, I realized that the power of the laser and the type, that really I think the only option for O&P that would be kind of resilient and durable enough might be like top-down DLP systems, which were several $100,000. So that's kind of when I took a step back and decided that wasn't for me.
Yeah, because then okay, yeah, now we're a couple years later, so there's more options and more different printers and stuff like that. So that, but I think if you need something durable like end use, it's going to be even today it's going to be quite challenging, especially if you want to be able to make it in like a one location and be kind of affordable,
Yeah. I think it was going to have to be a central fabrication kind of setup.
Yeah, maybe. Still to this point, the materials haven't gone better. Also for entry level systems, we've got some major investments by companies like Henkel and others. So it has gotten a little bit more interesting, I think. But yeah, for durable, like if you want to do something that someone's going to use every day, walk on, or do stuff like that, it's still going to be tricky. And also, these materials are very brittle, so if they shatter, I always think that the thermoplastics are a bit safer, I think, in certain sense. And the failure mode, even if it goes wrong, then it goes wrong a little bit more, less riskily, let's say.
Right.
In my opinion. Right. But and why didn't you just go for MJF? Because I think you did mention MJF, and I think a lot of people in this field really love MJF. And why did you dream of just doing it yourself? Was that really what you really wanted, or?
It's just a cost thing. At the time, the stuff that we were able to get's just too expensive. I don't feel that there's a great business case for a lot of MJF parts in L&P. That's changing, obviously, as central fabrication service bureaus come online and get more into it. And maybe Brent has more experience and can tell me if I'm right or wrong on this, but it seems like with MJF, it's such a big initial investment and ongoing maintenance investment that it's really got to be very specifically used. You have to pack the build chamber completely. It's best if you're in other industries where you can get smaller parts that might fit in and around things. So if you're not having a center print it for you, then to me, it's just not really affordable.
Yeah, I think that's a good point you bring that up, because like you guys would have a lot of big parts and it's really difficult to fill a build volume with them. It's also, you would really have to either centralize it for a number of O&P people, or like you said, a bigger variance in part is actually going to make it easier to fill the build volume as well. So I think, that is an issue. But I think, did you think of working with a service, or was it just nobody out there that really, was able to do that for you?
It's just at this point, it's just not really something that is on my radar. Like, it's not where I'm at in the 3D printing journey. So I very specifically focus on non-structural components. I make flexible inner sockets. I make cosmetic covers. Those are the primary things. I make a lot of test sockets, which are kind of one-time use in a structured, controlled environment. So I just personally haven't gotten into the structural side of things. And a lot of that is the things that I enjoy are kind of creating more dynamic sockets. And that to me happens at the interface a lot of times. So I don't really feel the need to go to the structural side. And beyond that, what we use already, laminations, because I'm primarily in prosthetics. So like a prosthetic socket that's laminated is only a couple $100. Our systems are well built out for that. Our fabrication centers are built for it, our processes, and really even our reimbursement and coding system is it's established for laminations. We have reimbursement codes, and this is something that is different across countries. So in the United States, we have reimbursement codes specifically for acrylic resin or similar, and ultralight materials, which they call carbon fiber, fiberglass, Kevlar, things like that. So we actually get paid to fabricate with those things. So when we look at like a definitive prosthetic socket, and again, this is my opinion. Everyone's got their own take on it, but this is the way that I read things and interpret them. If we're making a definitive socket and we're not laminating, if we're, say, doing an MJF socket, we're already paying more for that MJF socket than we would be for the lamination itself, which is only a couple $100. And on top of that, we're losing billing codes that could be with Medicare up to maybe $900 or so. So to me, the business case just isn't there for it.
Okay. I think that's an interesting way of looking at it, actually. And I wouldn't know enough about this. I mean, I think, what do you think about this, Brent? Do you have a different opinion, or?
So I understand where, Derick comes from, and my opinion comes really around what are the benefits for multi-jet fusion, but then also what can be done to a definitive socket multi-jet fusion to be able to get those codes. And I don't think that is part of the discussion today, but those are the things that I think about where I have no qualms modifying, designing sockets to incorporate some of the things around those L codes to go ahead and get them.
Yeah, definitely. I think that's a great plan, Brent. I do think that's the future too. I just, for me, haven't gone there yet.
Okay. So what printer did you buy to start off with when you were starting with the 3D printing thing? And what did you make? What was the business case for you? What finally made you get the printer? Was there a part? Was there
It wasn't a business case at all. So it was actually just a curiosity thing. I just wanted to do it and learn it. For the first year, actually the first several years I was printing, I wasn't really using them on my patients in practice. Maybe dabbling a little bit here and there, but I was working at a place that just wasn't, they didn't really want to get into those kind of things. So a lot of it was just me learning and teaching myself in the background. And then early this year is when I started my company, educating others on this. Really, I started with the resin printer was a Peopoly Phenom L. So I got basically the cheapest desktop one that was big enough to print prosthetics. And then the first FFF printer that I went to was an Ender 3 V2, and quickly started modifying it, made it 500 millimeter Z height, and kind of went from there.
Okay. And now, what do you mostly do with it? What do you mostly do with printing, like day in, day out? Let's say.
Yeah, so my kind of the workhorse of what I'm doing. I've got, I think, 6 or 7 filament printers now. And I'm working on setting them all up to do different things. So a lot of it is just PETG test sockets. I've basically got one printer dialed in with some design profiles and some slicer profiles for that, where I can print BK test sockets in 2 to 3 hours on a printer that's less than $500. So that's on an Artillery Sidewinder X2.
I have one of those. They're actually not bad, huh?
Yeah, I mean that's what I've recommended to people to look into first. It really just, for the price point, it checks all the boxes of getting started, and that's kind of where I'm at with everybody, is just helping them get started. So it's big, it's a 300 by 300 XY and then 400 millimeter Z height, so it can fit most of what we want to do. It's got a direct drive, maybe not the best one, but it's got a direct drive extruder, so it really can allow people to just start learning and doing everything we want. And then it's got the Volcano hot end, or a clone of it. So I actually ended up putting a Bondtech CHT nozzle on it, the 1.8 millimeter nozzle, with a Volcano adapter that CNC Kitchen made. If you've seen that YouTube channel, anyone who hasn't seen that, check it out. I've learned basically everything I know about how to print well from different YouTube channels.
Could you recommend other ones? Because that's good. You bring a CNC Kitchen. I like, by the way. The other ones that you think they were pretty useful for you?
So Tom, I don't know what the channel's called, but was it Thomas Sandlanderer? I think. I really like Tom and Stefan. Just the way they approach things. They approach things very scientifically, and then they show things that are useful. So I've learned a lot about, specifically from Stefan, which is CNC Kitchen. Like, he approaches it from an engineering standpoint. So I've learned a lot about how to print strong, how to print fast, clean, what all the different things that I'm looking for. Because really in prosthetics and orthotics, our needs are different from a lot of people who are 3D printing. A lot of times it's like people want a small printer is okay. They want small nozzles, fine detail. They're making things that are, just, knickknacks or something to, show off. Like, we're using those same printers, but we're trying to use them in totally different ways, where a lot of times we want things fast. We want them robust. So I've really appreciated that from the engineering side. So those are the two main ones, is Tom and Stefan's channels. And then, I basically just watch anything I can find beyond that.
Hey, Derick, just curious and I know I've watched some of your stuff, and I'd love for you to explain some of your designs specifically for 3D printed check sockets. What is your thoughts around vase mode, not vase mode, that sort of thing? Because I think we're probably more similar along those lines, but I'm just kind of curious to hear your thoughts on that.
Yeah, I think we're probably pretty similar too, from what I've seen of yours. I don't care about vase mode at all. It means nothing to me.
Oh my God. Okay.
Sit down, Yoris. Put your seatbelt on.
No, come on.
For my cosmetic covers, I'll use it just to have the cleanest outer surface. So I will do a 2-part cosmetic cover with a vase mode shell, and then like an inner that fills out the space. But for test sockets, like I don't care about a seam at all. I don't think it's a weak point. I use wipe settings to make sure I overlap my seam. It doesn't matter. In fact, I primarily consider myself a designer, not a printer. And for me, vase mode is limiting on my designs. So there are certain things that we can't do with vase mode that we can do better when we just don't use it. So we can get detail into our prints, which allows, sometimes better surface quality, but also just more complex design. But then also the materials that we use, primarily PETG and TPU, they aren't, to me, the best things to even be printed in vase mode. So TPU, you can't really print it all that fast anyways. So printing it a little bit, slower is fine. And then PETG, if you get too hot on your layers, they're going to slump and start to collapse on each other. So the vase mode, when you go for bigger lines, it's got that higher thermal mass and doesn't cool as well. And then you're going to have to either slow down a lot or increase your layer cooling, your cooling fan, which comes at the expense of strength and layer adhesion. So for me, the vase mode, like if I was going to print something, for example, like a 5 millimeter wide line, I'm going to print that at half the speed that I would print something if I was using 2.5 millimeter lines. So I don't actually lose any speed at all. It just changes the way I design and print.
Yeah, and to go along with that, Yoris, I think this is what's very interesting, and I think this is where, and I don't want to put words in your mouth, Derick, we see it very much the same. Like, the vase mode is great. You do get strength and all that, but it does create waste, and it introduces some variability from what you actually design. So when you design in vase mode, you have to do the socket all the way across the kneecap, say if it's a below the knee socket, but then either somebody has to draw on that socket and cut it out and create a piece of trash essentially and throw it away. And then, so you're introducing variability into your fabrication of these sockets. Whereas when you 3D print not using vase mode, your trim lines are built in, everything is as designed. Sure, it can be wrong, but it's wrong because the design is wrong, not because somebody slipped with a cast saw or a jigsaw or whatever and needed to go a little bit deeper. So in my opinion, the waste factor is much greater, and that's something that we're trying to get away from in prosthetics and orthotics than the gains of strength. So Derick, I don't know if you have anything to say with that, but
yeah, no, I agree 100%. So, I mean, cutting down on waste, that's really important to me. So when I look at 3D printing for O&P, I approach it from a couple different views, depending on where you're at, really. So in the United States, resources aren't an issue for us. But the flip side of that is our insurance system sets our reimbursements. So we're not going to get paid more for the stuff we make. It's just not going to happen. Maybe slowly over time, but nothing big. And the parts that we buy from manufacturers are going to keep going up in price. So really the only place that a business can save money is the fabrication side. So cutting down on waste is a huge part of that. So that's where I think I like 3D printing for O&P in the United States specifically is it's a way to be more efficient in our business and increase our profit margins and the health of the company without negatively impacting patient outcomes at all. Because that's the big thing, is we don't want to do anything that makes things worse on what we do as clinicians. So I think it's a way to make things equal or better, but improve our profit margins and lower our fabrication cost. And then the other side of it is other countries. So developing countries around the world where resources are limited, they might need to use 3D printing exactly for that reason, because resources are limited. And from that same side, we don't want them wasting material just to try to use vase mode. So yeah, I think there's a lot of reasons not to.
Okay. I think I hadn't appreciated the fact that you would have to do the manual cuttings, and of course that introduces a whole new era. I think that's a really, really good point. I do think that just it allows you to really target, to really adjust your G code and adjust the whole print specifically for strength. And I thought, with going for that, I really, really like it. But again, if you need an extra cutting tool operation thing on it, then yeah, it does seem to indicate a lot of risk. And I think it's a really good thing what you guys are pointing out about the waste. I think that's really good as well.
So yours, question for you.
Yeah.
What, talking about using vase mode to increase strength, what strength do we even need to increase would be my question. What is it about non-vase mode printing that's not strong enough?
No, I'm just saying that we could target more by shaping the layers and making sure that we can get the layer appropriately to bond more properly, and to focusing on that, we can get the interlayer bonding to improve. That would be the idea behind it.
Yeah.
Because we're focusing only on that.
Right.
And we're doing this.
The other thing too on that is, you heard Derick say he's using a 1.8 millimeter nozzle extruding like 2.5 millimeters. So the thermal mass is still there, layer to layer, which you're not doing in a lot of just off-the-shelf printers. So the layer-to-layer adhesion with large nozzles is still I would say on par with the strength of some of these, on par, or the same as just doing vase mode at the same, thickness, just because of the large nozzle. I think that's the unique thing that, Derick is doing, is you're still getting the strength because you're extruding at a very wide width.
A wide track,
yeah.
Okay.
I think that's important. Then also you have to know your materials. So PETG bonds very well to itself. If you break a PETG socket, it's basically the same as if we thermoform them. They're just going to shatter. And they do that because the weakness isn't necessarily across the layer lines. If you break a printed socket and look at it, it's probably going to break top to bottom. And then you look inside and those layers are basically fully fused to each other. So there's very little that we're losing that way. And same with TPU. I'm using materials that bond to themselves very, very well. So it's really, from that standpoint, another reason it's not that important to me.
Yeah, and also the types of forces that are on it, right? You're not going to have much pull strength on this thing, right? This socket, right? It's going to be much more like the strength of the leg on the side of it, or the side wall and stuff like that, right? Rather than the thing being pulled apart, let's say.
Yeah, definitely. We have to look at where the weakness is. We like to pull out hammers and smash things, which is cool and fun. But that really isn't all that representative of real world unless there's some sort of an accident happening. I like the drop test because I drop stuff all the time. So I want to make sure that socket can fall off my workbench and survive while I'm, doing my appointment. But beyond that, it's really, and I haven't studied this, I would love to have an engineer look at this, or some of the schools do research on this. But to me, I think it's going to be more torque forces than anything. Our forces are going to be at the distal end, the bottom end plate, where the lock or other parts are attaching to each other, and they're really clamping around that bottom plate. And then you have your transition from horizontal to vertical, where it goes from that bottom plate to your sidewalls. And that's where all the torque's going to be applied. So it's really a matter of, just I print that bottom at 8 millimeters thick because that doubles up my surface area and doubles my strength there. So I look at it from that standpoint of, how do I design this better to be stronger where it needs to be and only where it needs to be.
Mm-hmm. Yeah. What I like about this approach, I mean, okay, by the way, we're skipping over some things that, first off, vase mode is essentially, well, you're printing in one continuous line. I think we didn't explain that earlier. So we're essentially going, instead of starting and stopping in different lines, which is really great if you're printing like a complicated shape, you're actually going one continuous line, which is not great for complicated shape, but has some advantages in some cases. But you're eliminating a lot of the cool things the 3D printer can do in making variable shapes. And the other thing we know, which I think maybe people would not have noticed, is a volcano nozzle is an E3D nozzle that's big at bigger things, let's say, right? Or better at bigger objects. And the printer, I think we need to dwell a little bit more on this. The printers you're using are just like super cheap, and I think that to me it means that if we are going to be doing something in the developing world, you could just literally say, "This is the same artillery printer I use in the States. Here you go."
That's exactly what I'm doing.
Yeah, so I love that. I love that very much. I think that's a very great thing. So what other printers do you use, just to figure out some other stuff? What other ones do you have? Or
let's see. I've got the Ender 3 that's kind of heavily modified. That's basically where I teach myself how to modify printers and different things. And I basically reserve that for when I need to print up to 5mm or 500 millimeters tall. But otherwise, I don't use that one a ton anymore. I have an Ender 6, Creality Ender 6, so Core XY printer with an enclosure on it. So I use that for kind of just general use, but specifically if I'm going to be trying to print nylons or polycarbonate, things like that need that enclosure. I've got an FL Sun. I've got a couple of them. I've got an original older one, a QQS Pro, I think, that I don't really use anymore. Replaced that with a Super Racer that is now my go-to printer specifically for VarioShore. Because I find VarioShore to be awesome, but also very finicky, very particular. And the Delta style printer gives me the most consistent print on that. So I use that there.
Did you do anything weird with the nozzle, or just like a standard, or what?
So that one also comes with a Volcano clone. With VarioShore, I actually print a little smaller. So just the way that I like to do them, I build in cushioning to my sockets. So I go for more detailed prints on those. So I'm only really using like a 0.6 millimeter nozzle on that. So I'm really not even using the Volcano advantages on that. It just happens to be on there.
Okay. And again, VarioShore, for those, it's a color fab, is the company material that has variable shores, a variable hardness, so you can vary that by essentially aerating the part, let's say, through a mix-in. So that's of course very exciting, because then you can get lots of different different properties for maybe creating some kind of cushioning, for example. So and I think it's interesting that you've got different printers set up for different materials. Do you think that's the way to do it? I mean, especially it's interesting because you spent maybe, I don't know, the most expensive one was like maybe the Creality 6 or something. That's like $500-$600 or something, right?
Yeah.
Yep. So you could have got an Ultimaker or something, you know what I mean?
Right.
But instead of that, you're like, you have everything set up for different materials. So there are advantages there, right?
Yeah. So a couple things. One is scalability. I bought one of these every few months as I found a need for them, instead of shelling out, thousands up front. And then just, I like having specific printers. I call them complementary printers that do one job well. I can modify each printer for that job. But they are still, able to do other things. So like if a printer goes down, because that is the risk of cheaper printers, is maintenance and downtime. If one goes down, I have several others I can transition that job to.
I like that. I mean, and you can also just for an extra couple $100 build in that redundancy by getting, two of everything.
Right. Yeah.
And what's your workflow? Do you use any kind of software, like specific software to you, or?
Yep. So I use iPhone scanners. So I've used Comb Scan in the past, but I actually use Scandy Pro now. I really focus on keeping costs low to make this, more accessible for everybody who wants to learn and follow along with me. So I use Scandy Pro as my scanner. I use Mesh Mixer, which is free.
I love Mesh Mixer.
I
I
think it's
love this so
fantastic.
much.
I mean, there's basically nothing that I can't do in Mesh Mixer. It's not always the cleanest workflow, but it'll do everything.
If I need to
Um,
make something from scratch, like some creative thing or something, I always use Mesh Mixer.
yeah,
And you know what? It's like it basically Chris Schmidt made that, I think, like years ago, and I don't think they updated. I don't think they do anything with it.
nope.
And it still works. It's still amazing. I love it, and I hope they never kind of get rid of it or something, because I know so many people that just like that rely on it either for a little bit of workflow or just occasionally. And for me, it's like creative, fun stuff.
Well, and I think it works perfectly for O and P because we use organic shapes, and that's what Mesh Mixer is good at. So it really works exactly as people might be used to with our kind of more specific O and P software that's been out over the years for modifications and such. It's a pretty direct transition from that to Mesh Mixer. The tool sets are basically the same. They work the same way. They're just not named things that are, we're used to in prosthetics and orthotics. So once you put in the time to just learn the tools and how they work, it's far more powerful than the software we pay people for otherwise.
Yeah. No, I think it's awesome, and also and it's free, right? I mean, and
Yeah, can't
what
beat
what
that.
are some other thing? What are some other stuff you use?
So I basically use those and Fusion 360. Anything that I want to do that is dimensioned, or really I use it a lot for Boolean operations. I think it gives much cleaner Booleans than Mesh Mixer does, specifically over the last year. So they're both owned by Autodesk. So Autodesk is working hard to bring those mesh tools from Mesh Mixer as they kind of sunset that out. And like you said, hopefully never get rid of it, but they just don't update it. They're bringing a lot of that stuff to Fusion 360, which is also very affordable. They have their student and kind of educational free licenses. And then if you're a business, it's $500 or less a year. Like you really can't beat it for the power of what it does. But they introduced a tool last year that in basically 2 clicks, you can turn your triangle based mesh that we get from a 3D scanner or out of Mesh Mixer, your STL OBJ files. With just a couple clicks now, you can turn that into a solid body in Fusion 360. Whereas before they introduced that tool last year, I was using multiple different softwares trying to convert it to a quad mesh and then take it into Fusion and make it a T spline and a B rep. So the workflows are coming together and becoming much more streamlined and simplified to where I basically now create a socket from in 10 minutes going from Mesh Mixer from a limb shape that's smoothed and ready. And how you get there is up to you. A lot of different, approaches on that. But from my limb shape as a starting point, I create my 4 or 5 millimeter thick socket that I want, the kind of generic just extrusion in Mesh Mixer, and then I kick that over to Fusion 360, where I have my repeatable, dedicated workflow for the lock dummies and the different bodies, and I just basically bully them together, and that's it. It's done.
Okay. And did that when you started out? How long would that take you normally? What's the time saved by like optimizing this?
Um, a lot of it's just learning and practicing and getting good at using the tools, but I would say these things used to take me at least 30 minutes, uh, maybe up to an hour if I was trying to, do a complicated one where, I mean, yeah, a straightforward case is easily 10 minutes now, maybe even less.
Okay. And for slicing?
For slicing, I use several. And again, I like to use different ones based on the features they have in the project I'm doing. So for the VarioShore sockets I'm using, where I'm building cushioning in, I use Cura because of some of the different travel paths. One of the things with VarioShore is it just oozes like crazy, and that can get very messy. So I like some of they call it combing in Cura, but some of the travel paths can keep that ooze to the inside walls or within the infill. So I think that helps a lot to make very clean VarioShore sockets. But otherwise, I use Super Slicer a lot, which is a lot of people might not know about that one. So Super Slicer is a fork off of Prusa Slicer that has had a lot of extra features added on. So it's kind of like a combination of Prusa Slicer and Cura together. So I use that a lot. It allows some options for variable settings, so different processes at different heights or in different regions, which I really like to use. Because I used to use Simplify 3D a lot, and I still do for some things. And I especially used that for varying my process based on the height. So I can do some of that in Super Slicer now. But yeah, it's basically those three: Simplify 3D, Cura, and Super Slicer, depending on what I'm doing.
Yeah, I like Super Slicer because for a long time it looked like it was like, it was Cura or nothing essentially,
Yeah.
and because in the beginning it was like Kiss Slicer and you had all this stuff, and then so I think Super Slicer came out as like, to me it felt like it was like no one had ever heard of it, and then all of a sudden you found like pockets of people using it. So I thought that was a really good development to have something that's that good come out of nowhere. This ice, what is it, the ice one as well? So it's good to have competition there. On the same time, Simplify seems like it's kind of treading water or something. I don't want to be mean or anything, but it just seems like it isn't going anywhere fast. Let's say so. So I think that on the slicer thing, it is. I think it's smart of you to just have multiple things going on because we don't really know what's going to work for what.
Yeah. Yeah. Last I heard, Simplify was promising updates before I was in 3D printing, and they haven't happened. So I don't know.
Yeah. You didn't get version 5 yet? I mean,
Yeah, I did a comparative analysis on that once. I'm like, I'm not sure why people are paying for it. But I thought it was like a very camish workflow, and I thought that really would appeal to those kind of people. I think the killer thing about that was at one point you could just define where you wanted and where you didn't want support, and I thought that was nobody else could do that at the time, I think. So I thought that
Right.
was that was it was interesting to have other people working on the problem, but it just at one point it just seemed like it's kind of like not much is happening kind of thing,
Yeah. Have either of you guys used the Fusion 360 slicer? I have, for whatever reason, I just haven't gotten around to that one yet, but I really need to.
Yeah, it's I just used it once because I was like, what? You can slice it in 360? But then I never actually used it again. So I have no idea if it is actually like any good,
Okay.
I have not. I looked at it yesterday, actually, believe it or not, when we were doing some parts, and it looks like they're going to have some MJF stuff in there as well, too. So I don't even know what that's going to look like. So they must be introducing some stuff like NetFab, like the builder, where you can pack your own builds in Fusion. So that'll be interesting.
I mean, yeah, Autodesk has so many programs and tools that it seems like in a way they're trying to centralize some of it into Fusion for the low end. So I could definitely see a future not too far away where everything we need to do in O&P can be done from start to finish within Fusion 360.
Yeah. But that's actually kind of interesting because, like, in the dental world, which is like, I think I still keep coming back to the dental world because the dental world is a lot of chair side stuff. There's a lot of like also people that are not per se engineers, but they're using it in their own practices. There's also labs, there's kind of very similar structure to the MP industry. And we see there a lot of propositions of people making a printer, a material, and software, and the whole workflow for dental. And we just don't see this happening for OMP. Is that do you miss that, or is that like, do you not really care much for that, or do you think it's a different market?
Yeah, I don't know. I know those other markets are into this more and they're far ahead of us. And I just haven't really ever seen enough of them to really know directly how they would translate.
But it seems like really tempting for somebody to develop exactly the workflow you need as an OAP person, with exactly the things right for you. It just seems really tempting, but and it seems like there could be a quite a sizable group out there of users. I'm just a little curious why nobody's doing it.
Yeah, I mean, I think people are trying to make a lot of O&P specific software, and there's actually a bunch of groups popping up doing it right now. And in some way, they're all competing to be the one that people actually adopt. But I don't know. I think we're still at this point where, to me, we're several years off. I think if you look at the adoption curve, like a technology adoption curve, I think we're still on the far left of the bell curve where we're maybe slightly past innovators, the first 2% or whatever, and getting into the early adopters. But I think we're early. I think we're really early still.
Okay. And what do you hope what do you hope to do then with your own experimentations? Do you have a end goal in mind, or do you have something you're working towards? Or
Yeah, I mean, I use my stuff on my own patients in my own clinic, and beyond that, like through my company Limb and Lattice, which company's a loose term. I consider it more community. Company basically exists on paper so that they can tax me at the end of the year. Uh, but it's a community where I'm just looking for the people who are like me and who want to learn and put in that effort and figure this stuff out up front and really just get out ahead of the curve. And I basically want to just offer a way for those people to learn easier because the learning curves are huge. I was able to do a lot of this because I have a CAD background, and it's just something I love and I understand. But beyond that, I want to find the people who want to learn and help them do that.
Okay. Well, Derick, sounds great. So head over to Derick's site and stuff, and if you want to hang out with him and learn from him. And I think we have today. I think we had an interesting discussion. But I need to relook at. I need to look at. You guys really made me think about vase mode now. That's one thing I didn't expect. I didn't expect that at all. Actually,
I love throwing you a curveball. Hey, before Derick leaves, I do want him to share a little bit about the stuff that he's doing in Africa. It's really neat, and how he's investing in a young man there that seems to be doing pretty well. So, Derick, if you can share with us a little bit on that.
Yeah, definitely. So Taiwo is in Nigeria. He reached out to me maybe at the end of last year, and he was just super excited. He was just looking for help. He saw digital and 3D printing and thought, this can help me change things for my community. And he just reached out and started asking questions. And, what I saw in him was just that excitement and that desire to learn. And I started kind of giving him, throwing him some questions and asking, and found out he had some experience with Blender. So he knew a little bit about 3D modeling. And I just started kind of giving him tips about Mesh Mixer. And very quickly, he showed me that he was willing to put in the time and that he's a really quick learner and he just understands this stuff. So through Limb and Lattice, I put together a little donation page, and we collected enough money to send him an artillery Sidewinder X2 and a bunch of filament to get started, and some of the filament dryer and some tools where he could just start learning and basically prove out that if we give the right people the right tools, and it doesn't even have to be expensive. We're talking less than $1,000 US, which to us, it's not a huge amount of money in some ways. Some people might disagree, but from a company standpoint, it's not a huge amount of money. But over there, like, that is life changing. That can start a business basically. So that's the whole thing, is now like this idea that you can start for less than $1,000 with a printer and software. And, we sent that to Taiwo, and he's doing it. He's proving it. Artillery actually pitched in and sent him a printer also. So he's got 2 Sidewinder X2s now. But yeah, I mean, he's printing stuff every day. And I mean, I think he's doing great. And I think it just shows that if people put in the time, like, you can learn, you can do this.
Yeah, it's. I think that's really good, really inspiring. I think imagine you could just send them a kit, and then that would be enough, right? With the
Pretty much,
videos
yeah.
and with everything, with the video and the training and all the course material, that would be amazing. Because then you could just, instead of having to go there all the time, you could just pitch 100 of these kits to people. Let's say it's like it would be $100,000, and then some of them will figure it out, and some of them won't, and then the ones that will figure out can themselves make their own. Make their own world for it, So I think that's really very exciting.
Yeah.
Yeah, I thought that was great. And so Brent, thank you for being here as well today.
Yeah, this was good. Thanks, Derick, for sharing kind of your journey as well. And I hope some people really can glean some nuggets of wisdom along the way and get started. So thank you for what you're doing to bring awareness around the 3D printing side for O&P.
Yeah, you're welcome. And thanks for having me on, guys.
All right. And thank you for listening. This is another episode of the Prosthetics and Orthotics podcast with Brent Wright and Joris Peels. And have a great day.